Okay, well, hello everybody, and welcome to another presentation of the online ColdFusion Meetup. I'm Charlie Earhart, and I'll be your host for the next hour or so. And in this edition, our 245th, being recorded on Thursday, July 21st, 2016, at noon U.S. Eastern Time, we've got Brad Wood, who's going to give his talk, "What's a Pull Request? Contributing to Open Source." And with that, I'll stop sharing, and Brad, you take it away. Thanks very much for coming on.
Thank you very much, Charlie. This is the session that I did for our Dev Objective conference. That was a few weeks ago, and Charlie asked me to present it online to get it recorded for posterity's sake, and of course to allow people who didn't attend the conference to be able to see it. So I'm honored to be able to present it to you guys today. I do have the chat window open, so feel free to ask questions while I'm talking. I'll try to keep an eye on that, and I have no problem stopping to discuss something. So if you haven't heard of me, I've been doing ColdFusion for a few years. I started about version 4.5, I think, back when I was in college. I'm a bit of a geek. I love Android. Love to hate on Apple whenever I can. I blog over at Coders Revolution as well as the Orta Solutions blog. I'm the ColdBox platform evangelist, though I've actually begun using the word developer advocate lately just because it seems like it's more hip. And what am I if I'm not hip, right? A bit of a musician, shade tree mechanic, and of course, I'm married with 3 beautiful girls who get all their good looks from their mother. So, we're going to talk about open source, getting off your duff, source control, double rainbows, a little bit of GitHub, and then we're actually going to submit a pull request. So, this session is mostly designed for people who are not that familiar with open source and what it is and how it works. If you're pretty familiar with open source, this should be a good review for you. And the second big point of the session is for people who would like to contribute to open source. Maybe they've been asked to submit a pull request for their favorite framework or library, and they just really don't know how to do that. That can be a little bit of a hurdle to get over, so I aim to kind of demystify that a little bit. So open source software is a phrase that's been around for quite some time. The first time I heard about open source software was when I was in college, and it was in regards to mostly Linux and this entire idea that thousands of people around the world would spend hours of their time basically completely for free, right? Writing software that they would just give away. They would make the source code of the software available to anyone in the world, as opposed to closed source software. So open source software is free, but what does that mean? Free is kind of an overloaded term in the English language. And there's a phrase, gratis versus libre. Richard Stallman has a quote that says, "Think free as in speech, not free as in beer." There's 2 different kinds of free. Free beer doesn't cost you anything, right? It means that it incurred no hit on your wallet for you to get that beer, but you may not have a choice over what the beer is or what bar it comes from, right? Free speech is something that's unlimited isn't quite the right word, but it's something that's unfettered. It can go where it needs to go. It's more of a free spirit kind of free. Open source, and we'll get to this in the next slide here, typically doesn't cost money, but more important than that, it's free, meaning that the community is able to take it where it needs to. It's not controlled by one single entity. Not all free software is open source. For instance, I used to use a Metapad or a Notepad replacement called Metapad for years. I actually still do. And the source code was not available for a long time, but it cost me nothing. And of course, not all open source software is free. Many companies will pay for things like Red Hat Enterprise Linux. The source code's out there, anyone can use it, but if you want to use an official licensed version of Red Hat Enterprise Linux, you pay money for that. So oftentimes you see FOSS, which stands for free open source software, but just so you know, it doesn't have to be free every time. So most open source software uses something called a license to kind of control what you can and you can't do with the software. A lot of the ideology behind open source software is people wanted to not only create things and put them out there for the world to use freely, potentially without a cost, but they also wanted to prevent other people from taking their hard work and then trying to commercialize it or monetize it. So there's different licenses that are legally binding that you distribute with your source code, and they sort of control what someone else can do with your source code. Some very common ones are GPL, Apache, MIT, BSD, and there's a really cool website called choosealicense.com. Let's see if we can just pull it up real quick. If you want to go through, see if I can type this in correctly. If you want to go through and learn about some of the additional licenses that are out there, this kind of covers some of the main ones. So it has a nice little flow. So I want to be simple and permissive, right? You click on that and it says, well, you should look into the MIT license. So it allows people to use your software for commercial use. They can distribute it. They can modify it. They can use it privately. The only condition is you have to include the license and copyright notice, which is pretty much standard. And the only thing you can't do is hold the original author liable. So that's the MIT license in a nutshell. What if you're concerned about patents, right? That's what directs us to the Apache license. Again, you can use software commercially, you can distribute it, you can modify it, you can even patent it, you can do private usage, but conditions are, again, you have to state the license whenever you distribute it, and you have to state any changes you've made to the library. And you not only can't hold the original party liable, but you can't use their trademarks either. And of course, if you're concerned about sharing improvements, then it sort of funnels you over to the GNU license. GNU is a recursive acronym that stands for GNU's Not Unix. This has more conditions. First of all, you have to disclose the source code. So you can't release a product based on an open source GNU library without disclosing the source code modifications you've made. It's also known as a viral license or a copyleft license. That means that it's only compatible with other software of the same license. And you have to state, of course, the changes you've made, and the limitations are you can't hold them liable. So there's really hundreds, probably thousands of licenses out there on the internet. The main licenses you see are typically Apache, GNU, sometimes MIT. I think there's even a Creative Commons license that's pretty much one of the most open licenses ever. If you want to contribute to something open source, you don't necessarily have to know too much about the licenses. They're more of a geeky thing to read into. If you're looking at forking someone else's project, meaning creating your own copy, and then maybe creating your own library based on someone else's work, you should probably at least glance at the license and see what it is, just to make sure that you're not doing anything illegal, make sure everything's kosher. So that's choosealicense.com. A lot of times people think of open source as a library that somebody writes and they just kind of throw it out there on GitHub, and that's it. It sits there and it rots away, and it's kind of a use at your own risk. And oftentimes that is true. But oftentimes you can actually still charge for things like support or training or even feature development. And so this is how a lot of open source softwares can be supported and even monetized. I mentioned Red Hat Enterprise Linux earlier. You're paying money to use it. Well, actually, that's sort of a bad example. Let's use something more like ColdBox, right? The ColdBox framework for ColdFusion. There's no charge to use it, but it doesn't mean that it's without support or without training. If you want to pay, you can get professional support through Order Solutions, and that's a very common model. You have software that's available for free. You have some sort of services around it. The companies can still make money. So if your company is thinking about releasing something, or if you're personally thinking about releasing something that's open source, that doesn't mean you can never make money off it ever. It just means that you can make money via other means, or maybe via some sort of enterprise features. One of the biggest tenets of open source software is that everybody can view and understand and modify your code. One of the worst things about open source software is everybody can view and understand and exploit your code. So there's sort of a double-edged sword here. And some people like to play both sides of it, and honestly there are two sides to the sword. It can be a good thing that your source code is visible. People can help fix bugs. They can make sure it's secure. It can also potentially be a bad thing. I don't think security through obscurity is a good method of security, but let's be honest, a lot of companies use it. There's, software is closed source, and that by nature makes it a little bit harder for, for hackers to be able to exploit the bugs that might be inside of it. We'll talk more about that in a few more slides. So you might be wondering, what are some reasons why you would want to release open source software? Some of the big things are open exchange, collaborative participation, basically having a community-driven software, being able to get feedback, from people around the world, helping build something together. Transparency is often very important in open source softwares. You'll have some sort of public bug tracker. You'll have, public committees that decide, features for maybe an open source language. You can see the actual code changes that are made, so it's a very transparent organization. Meritocracy is a phrase that basically means that your merit in the community is based on what you've done. So therefore, if you get out there and you contribute to things and you're active in a community, it's sort of a fancy word for street cred, if you will, right? It's the idea that you can be somebody, you can be important perhaps in a community based on your actual contributions to that project, not necessarily because you have money or because you own the company. And of course, just the community in general. None of these things are unique to open source softwares, but they typically are really important. Now, from the other side of the coin, why would you want to use open source software? Oftentimes, it's less restrictive. If you're not paying money for a license, then you want to do cloud deployments, then it might not be a big deal to suddenly go from one deployment to 50 deployments. Whereas if you had licensed software that came with more restrictions, you would have to pay more money, or you'd be more restricted. It can oftentimes be easier to debug, assuming that you understand the programming language this library is written in. You can go and you can view the code for this library. You can figure out what it's doing that's wrong, and possibly even fix it. It means it can be modified. Most open source softwares will have some sort of instructions on how to build it yourself. So, for instance, if you're using Lucy server and you want to fix a bug that's in there that you found, you have the ability to find the bug, fix it, and create your own build. Now that may be, far more work than most people are interested in doing, but at least you have the option of doing that. If this is a closed source software made available via some, commercial entity, those wouldn't be even an option. Oftentimes you can sort of avoid lock-in. Anytime you integrate a piece of software, deeply into your company, it's always a bit of effort to change it. But if you've paid nothing for a piece of software, you might be more likely to say, you know what, let's try this other PDF generation library because it doesn't cost us anything to switch to it. Whereas if your company spent thousands of dollars to purchase a certain library and then you didn't really like it, you'd sort of feel obligated to use it because you kind of invested in there. And then we have security and quality, the many I's. And this is the one that kind of goes both ways. A lot of people that support open source software will say our software is more secure, our software has higher quality because there's so many people looking at it. There's so many eyeballs around the world checking out our source code, reporting bugs, and so we have this grassroots effort to squash any security holes. The flip side of that coin, to be fair, is that really only works, in my opinion, when you sort of have a critical mass sized community that can actually do that. Just because I write a bit of code and throw it out on GitHub doesn't actually mean it's secure nor a quality piece of code, because there might not be anybody actually looking at it. So you always have the other side of the coin, that just because people find bugs in an open source software doesn't mean they report it. They could just take that and use it to exploit it internally. This is why a lot of softwares will actually open up bounty programs, and they'll say, if you find a bug in our software and you can show it to us, we'll pay you a certain amount of money. That way they try to encourage people to report bugs that they find, as opposed to just trying to privately exploit them. So security and equality can go both ways. I've seen people argue it from both sides. And since we're being fair and talking about some of the disadvantages, there are a few reasons you might want to potentially avoid some open source projects. The first is which is sometimes you have poor community support. Some open source projects are built by a vast community, and they have message boards and mailing lists and Slack channels. You name it. Other times you run across a cool looking project, but some guy in some other country wrote it years ago, and maybe they don't support it anymore. So it might be up to you to fix bugs in it. You kind of have to gauge that. When you look at a project, you look and see, are there recent commits on the project? Are there pull requests and issues stacking up in GitHub? If so, that might be a project that you're not going to get very good support. Small projects can dry up. We've seen that a lot in ColdFusion over the years. Frameworks and libraries that have use, and once the author moves on or stops using them, they kind of disappear. Oftentimes, you have a lack of documentation, right? Open source software is kind of by nature written by developers, and not all developers are crazy documentation people like Luis Mahano, right? They don't want to document stuff, and so you kind of just have to dig through the source code. So that's one of the things you can kind of gauge when you look at an open source project and you think, do I want to use this? You look and see, is it active? Does it have documentation? Are there people I can ask? A lot of times you can check Stack Overflow, right? See if there's a tag on Stack Overflow that people are using to ask questions and see if it's being answered. Sometimes open source software is blamed for having a bad user experience, user interfaces, and this can happen because it's developer driven. Doesn't always have a UI team working on it. I think Apache JMeter is probably a pretty good example of this. It's an incredibly powerful load testing tool, but it looks like a bunch of developers wrote the interface. It's incredibly complicated to wrap your head around. That may or may not be an issue for you, but it's something to think about. And occasionally you have open source software that's sort of disorganized. If there's not a company backing it, it could just take a long time to get things fixed. So it's good to be fair with ourselves and talk about some of the bad things. Otherwise, I think I'd be cheating you guys a bit if I said open source software was always good. There's a few organizations that kind of aim to help keep the things in the previous slides from happening. There's the Apache Software Foundation. Of course, the Apache license comes from them. The Apache Web Server is part of this. Apache Tomcat. There's a whole ton of libraries out there that all start with Apache. In fact, the POI libraries that do spreadsheet manipulation are all part of Apache. Open Source Initiative, Eclipse, of course. These guys use... Actually, I think they have their own Eclipse license now that I think about it. They obviously maintain the Eclipse IDE. They also maintain, interestingly enough, the Java Git libraries that I use in Command Box. Whenever I have find a bug, I always go to their ticket tracking system. There's Creative Commons. They have their own license. These are basically organizations that help take in open source products. If there's a popular product, it's in the community, it's being used, but the maintainers have kind of moved on, but there's still people looking for support, looking for things to be fixed, looking for a documentation site, looking for API docs. These organizations will kind of take in an open source project, pull it under their wing, and try to organize it kind of on their website so it can still live on and not have the domains just disappear off the internet when the original author gets done with them. There's been a couple attempts in the ColdFusion community to do sort of the same thing. The OpenCFML Foundation, Team CF Advance. I think those have had mixed luck as far as actually finding enough active people in the community to do so. These are some of the organizations that were part of them. You see it's a little bit of an old slide deck as I saw Rilo on there. So let's talk about how you guys can plug in then. As developers, you probably use a lot of open source libraries. In fact, you may use more than you realize. A lot of people may not even realize that even Adobe ColdFusion, which is obviously closed source and commercial, is built upon a huge swath of open source Java libraries all under the hood that have all been manicured and put together for you. So even when you use commercial products, oftentimes you're using open source libraries under the hood. So it behooves you to want to be able to help and maintain these projects out there. So things you can do are just staying current with libraries, making sure you're keeping updated. If you use a project, maybe check their blog or follow them on Twitter so you can see when there's bug fixes or security vulnerabilities, especially. Companies like Adobe might put a lot of effort into advertising their security fixes, but a small open source project, you may have to actually follow their blog to see that. Ask questions. Asking questions has the obvious benefit to yourself of hopefully getting an answer to it, but the secondary reason for asking questions is that you build up, assuming you ask them on a medium such as Stack Overflow or a Google group, which is persistent on the internet, You build up a collection of of questions and answers out there that help people that come along behind you who are going to have the same question. And of course, once you've gotten involved in a project enough, you can answer questions. You can go on and subscribe to the mailing list and keep an eye maybe on a Slack channel. When you see someone come along and ask a question that you know the answer to, go ahead and contribute back. We've all been in the position where we're looking for an answer. And so, try to help with the other side of the coin and answer that. And even if you don't know the answer, I'll be honest. A lot of times, I spend a lot of time on the cold box and the command box mailing list. I don't always know the answer when people ask questions. But if you have some free time, look at what they're doing, try it yourself, see if you can figure out the answer, and give back. Right. Another easy thing you can do is reporting bugs. This takes a very small amount of time out of your day. If you find a bug and you're fairly convinced it's a bug, do some due diligence, right? Oftentimes you might think it's a bug, but it turns out you're just not using the library correctly. But if you see a bug, especially if the maintainer in the mailing list says, yeah, that looks like a bug, go ahead and say, where can I put in a ticket for this? It might not get fixed right away, but at least it'll be out there on their bug tracker. Most projects on GitHub have a built-in issue tracker. Jira is also very common. And then finally, give back, right? And you can give back in several ways we'll talk about here. You don't always have to give back in code, right? One of the easiest ways you can give back to an open source project is with documentation. Documentation is pretty easy, right? Everybody can kind of do that. So if you had a little bit of problems installing a library and you thought to yourself, man, their documentation didn't quite cover my use case, ask them if you can contribute to their documentation. GitHub wikis are actually stored right there on GitHub. A lot of people we're using Gitbooks for a lot of our Ortus, the cold box and the command box, all those libraries. Gitbooks are actually stored as markdown in a GitHub repository, so people can literally send pull requests to our documentation. And I love it when people send little typos, grammar fixes, add little examples. That's something you can do. And there's also a couple great community projects, cfdocs.org that Pete Freitag is doing, and the docs.lucy.org. Those are all CFML documentation sites that are ultimately stored in a Git repository, and you can even add your own samples to them via pull request, which is a great way to contribute back to those projects. New features. Oftentimes, we've had a lot of pull requests to some of the box frameworks where somebody wanted a new feature and they kind of went and figured out how to do it themselves, and they approach us and say, does this look like it would be a good fit for the core framework? And we say, yeah, we'd love that. Can you submit that as a new feature? Of course, fixing bugs if you're comfortable kind of rummaging through the code and finding where the bugs are. And one of the simplest things you can do are just typos. A lot of libraries have little typos all over them, especially maybe if English isn't the primary language of the developer. And you can always go through and submit small little requests to fix little things like that, and those are always appreciated by the maintainers of the project. So if you're wanting to contribute something to an open source project, the first thing to do is to figure out where the source code is stored. The most popular one is probably GitHub these days. It's really grown quite a bit. Google Code, I think they pulled the plug on. A little bit old slide deck here. SourceForge, I don't see much stuff there. Assembla, I don't see much Assembla stuff either. Bitbucket is fairly active still. That's an Atlassian kind of equivalent to GitHub. They also do Mercurial repositories. We'll focus on working with a repository today that uses GitHub. I don't think I've seen a project hosted on Subversion in many years now. That used to be quite popular in the past. But find out where the source code for the project is. A lot of times they'll have that linked on their homepage. You can always ask. Whenever I help answer people's questions on a lot of the Coldbox mailing lists, oftentimes I'll try to go find a link to the source code on GitHub that shows where the issue is, just to kind of get them looking at the source code. So, source control. The State of the CF Union survey has been showing a good trend in the ColdFusion community of people adopting source control, but there's still quite a few people out there that are working on a daily basis and they aren't checking their their code into any kind of source control system. The cowboy coding days, right? A source control system is basically a method of managing changes to text-based documents. Typically, think of code files, right? CFM files, CFC files. Your changes are all identified by some kind of unique revision identifier. In the Subversion days, that used to be an auto-incrementing integer. With Git, you have a SHA-1 hash, which sort of by nature isn't greater than or less than any other revision, since they all kind of point to their parent commit. And of course, each of these revisions is associated with some kind of timestamp. When was the change made? A user, what person made the change? And in addition to just having the history of all of the changes that were made to a certain file, by whom and when, you can compare revisions together, you can restore old code, and you can even merge multiple branches together. People who don't use source control tend to do a lot of things where you have a bunch of files littered around your code that are all .back or underscore old, or underscore 1, underscore 2 kind of stuff. You have folders with underscores in front of them. That stuff is clutter in your code. And when you're using source control, you don't have to do that stuff. Doug says he's guilty. I used to be. But when you're using source control, the thing is you can always get back anything you've ever done. So instead of commenting out big giant chunks of code in case you ever need them, just delete them. Clean that code up. Get them out of there. Delete those old files. Delete that old code. It's always easy to go back and get it from an older commit and copy it back in. Don't try to keep 70 versions of the same file in the latest commit. Just keep the current version of the file. All those old things that you wanted to comment out, delete them. They're in source control, right? Sorry, that's a bit of a rant. So let's take a look at a GitHub repository. We're going to focus on GitHub today since it's kind of the king of open source projects. Our little rectangular shape here, our polygon with the corner missing, is a representation of the ColdBox framework on GitHub. I just use this as an example because I see a lot of pull requests for ColdBox. And inside of our repository, we have what's called a branch, and we use a branch called development. This is a common branch name you'll see in a lot of repositories, depending on if you're using Gitflow or not. And so this branch is oftentimes referred to as a line of code. And basically, each dot here represents an individual commit made by a person at a certain date where something changed in one or more files in that repository. And those string together to form a line. And the way that Git works is each commit is a pointer back to the previous commit. So the sum total of all these commits kind of add up to show you what the current state of the repository is. So on a development branch, we're making code changes on a regular basis. We're committing them, and every time we commit them, we get a little black dot here that represents something happening in that repository. A common thing you see are a master branch, which you'll see in most of our box repositories. Is pretty common. And the master branch will typically represent the release version of the code. And your typical sort of Git flow, you'll make your changes to the development branch first, and then you'll merge them at certain kind of milestones in the life cycle of the product into the master branch. So you see here we had 3 commits on development, and we said, okay, this is a good version 1 of our software, so we created our master branch. And at that point, let me see if I can see my mouse cursor. At this point, this little black circle and this little black circle are the exact same code, but in 2 different branches. So a couple more commits happen to development, and we say, you know what, this is a good 1.5 version. We merge those down into master, and we go ahead and we tag that as 1.5. A tag is sort of like well, I don't want to say it's a branch. A tag is basically a pointer to a commit, but it has a nice human readable name, right? Then we put some more commits on our development branch, adding more features, fixing bugs, and we say this is a really good stopping point for version 2.0. We merge those commits down into master, and again, master and dev match, and we tag that as version 2.0. So this is the typical workflow of a Git repository. Sometimes you will see people do it a little bit differently. They might use master as the branch where they commit their changes, and they may merge them into a release branch. There's about 1,000 different possible ways you can manage a repository. If you're looking to help submit some changes to a repository, the easiest thing to do is just ask the developers. Say, hey, where should I send a pull request to? Where do you guys commit your code to? In fact, as a good example, in Dev Objective, Misha did a deep dive for Lucy, and he was talking about how he manages the Lucy repositories. And he does his a little bit differently. He doesn't have a development branch. His master branch is what he releases, and he creates sort of long-lived feature branches that he merges in. So there's lots of ways to do it, but the easiest thing is just to ask. You'll also see a concept of feature branches. And feature branches are, in theory, a short-lived branch. There's different trains of thought out there on how long a branch should live. Typically, I always opt that a branch should live for as short as possible. The longer you have branches out there, the more versions of your code you have, and the more chance you have for conflicts, right? So let's say I'm going to work on a feature, and it's a little bit more complicated than just something I can finish off in the afternoon, right? So I'm going to go ahead and create a branch off of development. So the very first commit in my feature branch is going to be a pointer to this development commit here. And maybe it's going to take me a couple days to finish this. So I'm going to go ahead and do a few commits off of my own little world, right? So I'm not affecting other people's code, but I'm still able to commit my code to my branch. And then once I'm done and it's fairly stable, I can merge that back into the development branch. And Git even has some nice features where you can squash those commits all together and make it look like one big, nice, fat commit back to development. So typically you'll see a lot of little feature branches. In fact, some development shops will say that all work has to be done in a feature branch, every single ticket. I'm a fan of having fewer branches where possible, unless you really need them. I've seen people get mired in some pretty complex workflows with Git. Honestly, you start reading blogs and you see some of the really complicated things people are doing. My recommendation to people is always start as simple as you can, and then start adding, additional branching and things, as you find the need for it. But what you see here is typical of a standard Git flow, and this is also typical of pretty much all the box products. Oftentimes, people refer to a stable release or a bleeding edge. The bleeding edge is basically just refers to whatever branch it is that commits get committed to in a repository. So if I say, have you tried the bleeding edge of command box, that basically means, are you using the version of command box that was built with the code based on the last commit that I committed to the development branch. So the bleeding edge of command box changed last night about 1 in the morning when I added some stuff to it, right? The stable release refers to whatever branch that represents the latest stable release version of that code. So let's talk about a couple GitHub terms. If you've used some other source control programs, I see a question on feature branches. Mike, check out a feature branch. You're checking out the entire code base with the feature, or do you check out the dev line and then the feature? I'm not sure if I follow exactly what you're asking, Mike. When typically a developer would create the feature branch themselves, right? So you would have development checked out, and you would say branch from development, and you would give that branch a name, right? And so the feature branch points to a commit on the development line. If you ever used Subversion, right? When you created a branch in Subversion, it would actually copy the entire contents of the original branch, which is why branching was very expensive. So if you had 100 megabytes of code in your development branch and you created a feature branch, it would increase your repository size to 200 megabytes. Git is a lot more lightweight because branches are just pointers to other commits. So you can create 1,000 branches in Git, and it adds essentially nothing to your repository size. So your feature branch just points to a commit in the development branch, and the code in that feature branch is, as Joe Gooch pointed out, is just the accumulation of everything that was in the development branch up to the point you branched, plus any commits you've done in the feature branch, right? Anyway, I'll let some people in the chat finish answering those questions if you still have them. So if you're coming from a Subversion background, which there used to be a lot more people in ColdFusion coming from Subversion, some of the terminology with Git and GitHub could be a little confusing. And for one, GitHub, let's back up. Git is a type of source control, right? It's developed by Linus Torvald, the guy who made Linux. GitHub is a website that hosts Git repositories for you and then adds some additional things on top of that. So Git is not necessarily equal to GitHub. GitHub is just a website that hosts a web interface to Git repositories, right? So GitHub is distributed source control. This means that everybody working on a repository has their own little copy of the entire repository. Back in the days when you used source control such as Subversion, everybody had to be connected online to a kind of a master Subversion server, right? And everybody, when you checked in and committed files, it would commit back to that internal server. GitHub is distributed in that you can actually work on a Git repository when you're offline. You don't even need to be connected to the internet. You can be in an airplane at 30,000 feet, and you can be changing branches. You can be committing commits. You can be doing merges all locally on your computer. Forking is when you create a copy of someone else's repository, right? So a lot of times you go to websites and you see a little fork me on GitHub banner at the top of their site. That basically is encouraging you to go to their repository on GitHub, create your own fork under your name, and then make changes, possibly submitting them back. Pushing and pulling is a phrase used for essentially retrieving commits or just tags, branches, retrieving information from a remote Git repository, or pushing changes the other direction. And remotes are basically how distributed Git repositories talk between themselves. So when you clone a Git repository, which basically means you create your own local copy using SourceTree or GitHub for desktop or even the Git CLI, you don't just check out a single branch kind of like SVN used to do. You actually clone the entire repository, all the branches by default. Of course, there's always exceptions to these rules. By default, you get the entire repository. So you can switch, you can check out branches, you can make your commits, and then the way that you get those commits back and forth between your copy and somebody else's copy, perhaps the one hosted on GitHub, is via remotes. And the remote is essentially a URL that points to another Git repository. And we'll talk about two kinds of remotes today, origin and upstream. And I'll wait till I get on another slide to dig into those. A branch, we covered a little bit a minute ago when we were showing our example, the ColdBox repository. A branch is sort of like a copy inside of a repository. And then, of course, a pull request is sort of the grand culmination of what we're trying to get to today, which is when you submit a suggested change back to another person's repository. Okay, so that entire little blue diagram we looked at earlier, he's right here now inside of the GitHub website. So our big tan rounded corner rectangle is the GitHub website, right? And here we have the official ColdBox repository. So all those commits, all those branches, all those tags are all contained right there in that little blue diagram. So Bob comes along, and Bob wants to create his own copy of the ColdBox repository, so he forks that. On the GitHub website, there's just a button called fork that you click, right? So now there's two copies of the ColdBox platform. There's the official version that's owned by the ColdBox user, and then there's Bob's version. So it's important that to note Bob can't directly change the official ColdBox repository, and that's a good thing. Bob can only make commits and changes to his repository. Back in the day, you would have to check out like an SVN repository, and you would either have to get commit rights to that repository, which means that they trusted you quite a bit, or you would have to send them patch files. It's quite a bit of a pain. Nowadays, it's a lot easier. You just get your own entire copy of the repository. So now what Bob does is he has his clone, he has his fork on the GitHub website. So Bob clones his copy of the repository down to his local PC, right? So now we actually have 3 total copies of the Coldbox platform. The official version, Bob's fork on github.com, and then the version Bob's cloned down to his local hard drive. It took me a little bit to understand everything in this diagram when I started, so hopefully this will help you guys out if you're getting a little confused. So let's talk about those 2 remotes that I mentioned. Bob's PC, his Git repository will have 2 remotes. One will be the origin, and that points to Bob's version of the Coldbox repo on GitHub. The other remote is the upstream, and that points to the original upstream repository that's the official Coldbox platform, right? So Bob can push and pull all he wants from his origin remote because he owns that one, but he can't do either from the he can pull from the upstream remote, but he can't push to that because he doesn't have permissions to that, and that's where the pull request comes in. So our origin remote, Bob can push changes up there. He can also pull them down. If somebody sends Bob a pull request, right, that would be sent to his version on github.com. He would pull those down to his local clone. So once Bob makes some changes, he's going to want to make sure that his repository stays in sync with the upstream repository, the original Coldbox platform. Because the thing is, you may have cloned it 2 weeks ago, and you've been making some changes, but meanwhile, Luis got inspired, as he says, right? And he went and fixed a bunch of bugs on Coldbox. So now your repository is behind, and you don't want to have conflicts. You want to make sure that your repository represents all the latest changes on the upstream. So what you're going to want to do is pull those changes from the upstream remote to make sure that your copy stays up to date. Once you've made some sort of fix and you want to contribute that back, you're going to push that to your origin remote on GitHub, and then the pull request comes into play, in which you basically request that the upstream repository owner pulls your changes. You can't force them to do it. It's up to them. You may submit a pull request, and they may say, nope, we don't like that, and we're just going to close this. We're not going to merge it. Obviously, that's why you should usually ask first, to make sure you're on the right page. And that's kind of the whole flow between these 3 repositories. So you think about it, some really popular repos out there that maybe have 50 or 100 forks, there's a lot of copies of that repository floating around the internet. If there's 50 forks of Coldbox, right, there's 51 versions of Coldbox on GitHub, and probably at least 50 cloned versions. So there's a lot of different copies of the repository, and it can be yeah, David says no test, no pull. Yeah, oftentimes a product owner will tell you that they want you to submit updated unit test if you fix a bug or send an enhancement. So hopefully this model makes a little bit of sense. And in the remaining minutes, I'd like to dig in and actually kind of just run through this process. Let me know if there's any questions about all the arrows on this. Took me a little while to kind of fully wrap my head around that, which is why I enjoy kind of talking about it now so other people can understand it. To do this, I'll keep my eye on the chat so I see some people typing. To do this, you'll need a GitHub account. This is quick and easy and free. You just go to GitHub and you sign up. You'll need some sort of Git client. You can just get the Git CLI, which is just a command line tool. Some people swear by the CLI. I tolerate the CLI. I use it whenever the GUI fails me or when there's something I can do a bit quicker than the GUI. I like to use a nice GUI for Git, but I also like to at least know what the commands are doing behind the scenes. Otherwise, you can kind of get stuck sometimes. There's some IDE plugins like eGit. I haven't used eGit in a long time. The last time I'd used it, it was an alpha stage. I've heard it's gotten quite a bit better. There's GitHub for Windows, which is a .NET-based product that GitHub puts out there, and I think I'll be using it today for my demo just because it's so darn simple. SourceTree is probably one of the most popular Git clients. It's pretty powerful. It has a really nice little visualization of all of your branches and commits. And then there's SmartGit, which I haven't used in a while. I'm not sure if they're still updating that. And of course, you're going to need to have a bit of time and patience I still have to do a fair bit of Googling sometimes to make sure I get all the little parameters right when I'm merging things via the command line. So let's fork a repository on GitHub, right? Let's clone that repository locally. Let's make some changes and let's submit a pull request. It honestly only takes a few minutes. I mean, I've spent more time talking about it than it takes to do it, but I want to make sure everybody knows what to do. So I have a bunch of screenshots of the process in my slide deck, but we're going to go cray-cray here today and see if we can just do it live. At conferences, I'm always a little afraid my internet will drop out, but if my internet drops out today, I've got more problems than my demo. So I was clicking around, looking for something simple we could do. This is the new forgebox.io site, and I found this little project here that Eric Peterson did. Ooh, where'd it go? I figured I could submit a small fix, or not even a fix, just an enhancement to his README file. So we're going to jump over to the source code link on GitHub. So this is Eric's original project. I don't think he knows that I'm going to submit a pull request. He's probably going to wonder what the heck I'm doing today. I see he's not in the Connect meeting. So we have a little fork button. Hopefully you can see where my mouse is. In the upper right-hand corner, you can see it has fork and it says 0, right? So there's 0 forks. There's also no one that starred his repository. We'll go ahead and star that. Let people know you like their work, right? So I have a number of GitHub accounts that I have on GitHub. So it asks me which account I would like to use. If you only have one GitHub account, you won't be prompted by that. You'll click the fork button and it will just simply fork it for you. So there we go. That only took a few seconds. Now it looks like we just got returned to the same screen, but if you pay attention, you'll see up here in the upper left, it now shows that the repository we're viewing is BDW429S, which that's me, /CB properties loader, and underneath it says forked from lpete /CB properties loader, right? So the repositories look the same, kind of visually on the screen, but this upper part tells you which one we're viewing. And if I want to go back and view his original one, I can just click the name of it there, and it links me back to his original one. Once you've forked a repository and you want to go to your fork, a little trick is you can click the fork button again, and it'll say you've already forked this repository, and it'll just take you there. That's a nice little trick. So now that we've forked it, I'm going to use GitHub for Windows, or GitHub for Desktop, actually. They renamed it. I tend to use this program. This is a super simplified Git client. It basically does kind of just the bare minimum, but I'll be honest, sometimes all I'm doing is just basic merging and committing and pushing and pulling. I really get tired of all the endless checkboxes and drop downs and some of the other Git clients. So what I tend to do is I use GitHub for desktop, and anything it doesn't do, I just do in the CLI. I don't know, the other day I opened up SourceTree just to do something real quick, but this is a pretty simple program, and you can download it if you don't have any Git client at all. If you just search for GitHub for desktop. There you go, desktop.github.com. They have this for Mac, they have it for PC. If you're a little afraid of overly complicated interfaces, or you just like something that's super simple, you can download this and get this started. If you're really wanting to dig in and go cray-cray with GitHub, then you can get SourceTree. SourceTree is an Atlassian product. Okay, so what's actually cool is the integration with this. I can clone this directly from the website. So right here, back on my fork of this properties loader project, this green button right here says clone or download. I can just type open in desktop, and if I have GitHub for desktop installed, it'll pop up and ask me browse where do I want to clone it to. I always accept the default, which is in a folder called GitHub inside of my user directory. In fact, I'll go show you. If you're on Windows, by default it goes under Documents, GitHub, and here you can see all the crap I've cloned over the years with GitHub for desktop. A lot of these are actually off of Bitbucket. Some of these are actually GitHub for enterprise repos. You don't have to use GitHub for desktop for GitHub. And here we see a Steebox properties loader folder. This is our Git repository that we just cloned. on my hard drive. Though actually I did a bit more work. All I needed to do was right click and click Open and Explore, and that would have taken me to the same place. So interface here, we have a list of branches we can change between. It looks like Eric doesn't have a development branch. All he has is just a single master branch. So there's not really a question of where to send this pull request to. We can click on the History tab and View Branch. Let's see here. How come I don't see any history? This may be a bug in GitHub for Desktop. There we go. Every once in a while this program can be a little flaky, but it is free. I will say though, these guys are pretty good at fixing bugs. If you ever have any problems, you go to the About page and you click Contact Support. I've filled out this form a bunch of times, and I always hear back from a human being within like 2 days, which honestly is pretty good considering I don't pay them any money to use this. But at any rate, a little plug there. So here we see all the commits that Eric's put into his project, right? Each commit shows a nice little diff of what he changed from the previous version. So I'm going to make a super simple change. I'm not even going to open this up in an IDE. I'm just going to suggest a little bit of editing to his README file, right? I can't increase the font size, so I apologize. So he has these kind of inline code samples. Let's just spruce these up a bit. Access these in your ColdBox settings by using this, and we'll do a nice little code block here. There we go. You can also use it by injecting it with there we go. And let's see. Let's actually component. Let's actually make a full little component here. There we go. So very small, simple little enhancement to his README file, just making the code blocks a little bit easier to read. And we'll see if he accepts my accepts my pull request for this. So now that I've made this change, the Changes button up here at the top, Changes in History. Changes has a little blue dot, and we see there's one change. README.md file has changed, and the red shows us what it used to be, and the green shows us what it is now. So we get a nice little kind of inline diff here of what the code used to be and what we changed it to. If I changed more than one file, there would be a list of files here, and I could check the checkboxes and the ones I want to change. I always like to just do a quick review before I ever commit anything. Because sometimes you'll have a dump and an abort or some kind of debugging code, or you commented something out and you totally forget about it, and before you know it, you've committed it. So this is a really good way just to scroll through the file really quickly, make sure there's nothing in there that you don't want to send. Now, before I commit this, I'm going to go ahead and create a branch. You don't have to create a branch, but I always recommend creating a branch for each pull request. The first reason is just for organization. It kind of helps document that code in the pull request. If you're doing this for a particular ticket number, right, you can always name the branch after the ticket number. If there's no ticket number, just name the branch after what the branch is doing. The second reason for having a branch for each pull request is I may come up with a second enhancement I want to do tomorrow for the same repository, and if Eric hasn't merged my first pull request, you can only have one pull request per branch, because the pull request doesn't point to the commits themselves. The pull request just says, I want you to merge everything in my master branch into your master branch. Then that means everything, all the commits I've added. So I can't segregate 3 or 4 separate fixes and allow Eric to selectively merge them in based on what he likes, unless I put them all in their own individual branch. Then he can do one pull request, and it's different from the pull request on a different branch. So to create the branch, I'm going to click our little Create New Branch button up here next to the drop-down of branches. And I'm going to call this branch Update README, right? And you see a little warning here. I put a space in the branch name, which isn't valid, so branch will be created as Update-README. No problem. So I'll create the branch first. And now the branch shows up here in our list. So you can switch between branches, master, and update README branch. So I'm going to switch to the update README branch, and it did check out my branch by default, if you hadn't noticed. And now I'm going to commit this change to the update README branch, right? So update README to use code block. There we go. Tell him what I'm doing. He's going to wonder why I'm submitting this. Okay, so, and I like how GitHub for Desktop is very clear. Commit to update README. Yes, that's the branch I want to commit to. So I click the commit button, and there are now no current changes. Source tree, you have to stage things first and then commit them. I kind of like how GitHub for Desktop simplifies it. There's just a one-step thing. You check the box, you hit commit, you're done. So if we look in the history of the update README branch, we'll see a single commit in this branch. Now this branch points to the master branch, so all the commits in the master branch are inherently a part of this branch, but they don't show up as separate commits. Another nice thing we can do, see if I can get it to work, if I view the master branch, I can compare it to update README, and you can also merge them together from the screen, and it'll also show you the differences between them. I think I need to do it the other way around. Look at the update README branch and compare it to master. Yeah, I think that's basically what we were doing earlier. So it shows you the differences. Anyway, so another nice thing is, well, I'll show you both ways. Let's go ahead and publish this. If you can actually submit pull requests directly from this program, which I'll submit it. But let me show you how you submit the pull request from the website real quick. I'm going to click the publish button, and this will push my new branch up to the origin remote, which is my copy of the repository. And again, this wouldn't be necessary if when you submit the pull request from the program, but I want to push it so it shows up here in the website. Okay, so you recently pushed branches. Update README less than a minute ago. I've only got about probably 5 minutes left, Charlie. So if we look in the branch dropdown, we can see there's the master branch and there's the update README branch. Now, these only exist in my copy of the repository. If I go over to Eric's main repository, all he's got is master, right? There's no such thing as update README over in his land, only in my fork. So there's two ways I can submit the pull request. The way I used to do it is I would go to the GitHub website, and it gives you a nice little link here that says compare and pull request. So it notices I pushed a branch, and it says, do you want to submit this as a pull request? Now, the most important thing when submitting this is to make sure that you submit it to the right branch on the base fork. Now, Eric only has one branch, and that's master, so I really can't screw it up this time. If he had a development branch, and that was where he wanted pull requests sent to, I would want to make sure that I chose that branch off of this dropdown. We get a lot of pull requests that get sent to like the ColdBox framework, and people accidentally fork and they branch off of our master branch, and they try to send us a pull request to master, and we have to reply and say thanks for your hard work. However, you need to please make these changes to the development and send the pull request to our development branch, and we have to close the pull request and ask them to resend it. So make sure you check on that first. So if I click the green create pull request button here, that'll create it. But I'm not going to do that because I want to go ahead and create the pull request through the app, since this is actually, in my opinion, the easiest, quickest way to do it. So if I'm on the update README branch right here, I can just click the create pull request button right here, and it pops a little menu out. And the same thing I just talked about, making sure you select the right branch, it applies right here. From update README into, now you see it doesn't default to the right one, which honestly I think is a bit of a bug. The default branch is master, and you'll notice we have two branches here that say master. We have master and we have lpeat master, right? What's the difference between master and lpeat master? I don't think their UI actually shows you your upstream. No, all they show me is the origin remote. This is where the few times where I drop down into a Git shell. If I do git remote, which is the command, we see we have two remotes, origin and lpeat. Normally I would have named lpeat upstream because it's basically the upstream remote. So if we do -v for verbose, we see the lpeat remote points to that upstream repository. This is the official repository. for this project. So there's what's called remote tracking branches that are created in my local repository, and they basically track this upstream repository. So any branches that are lp slash something, it points to Eric's upstream repository, right? So that kind of answers our question, what's the difference between master and lp slash master? Master is my local master branch in my repository fork. lp slash master is the upstream, the far away master branch. That's the one I want. That's where I want to actually send these changes to. So if you don't get anything else right, make sure you double check this and you're sending this to the remote upstream repository in the right branch. Now, like I said, it doesn't have a development, so master's where it goes. So make sure your little message here is descriptive. If you send somebody a pull request that just says updated something, they're probably going to be like, what the heck is this, right? So reference your ticket numbers, make a description, whatever you need. You even get a nice little message that says this pull request can be automatically merged. What that means is that in the last 5 minutes, Eric Peterson didn't go and make a change to his README file, which would conflict with my change. And that's a good thing. That means that everything is all kosher. So the send pull request button here does the same thing the send pull request button on the website would have. It's just all nice and integrated right here in this program. And I can even click here, view on GitHub, and here's my pull request that I created. So opened by me, I want to merge one commit into LP master from BDW429S update readme. So you can read that like a sentence. That's everything that we're doing. We can see how many commits are in it. There's only one commit. There can be multiple commits I had added. And you can also get this nice little file diff again under files changed. When I get pull requests sent to my repositories, first thing I do is I come in here, I look and see what they changed. And we can also have a nice little conversation. I can say, hi, I can even tag him with his username. I'm submitting this as part of a prezzo I'm doing right now. Smiley face, right? So we can talk about it, and he can come back and he can comment. We can have discussions. Another really cool thing is Eric or I can both come in and we can click this little plus sign and we can add line comments. I thought this might be more readable, right? So he can ask questions and say, why did you do this? I don't understand why you did this code. Why should I pull this, right? And you can put these comments on a line-by-line basis, and we can have a little comment thread right here. And this is super handy to kind of, hammer out. And if he wants me to go make some changes, I can just make those changes, commit them to my update README branch, and push them, and they'll automatically be a part of the pull request. And of course, everything shows up right here. So when he gets online, he'll come see this. He'll probably scratch his head for a minute and wonder why I'm sending this. And he'll have a big fat merge button that he can click, and it'll automatically merge it into his repository. And that's basically the long and short of it. If I did this all over again from start to finish and I didn't talk, it would take about 2 minutes probably. So once you kind of understand the concepts and you learn your way around a tool for interacting with Git and GitHub, it's really not that big of a deal. At least the plumbing of creating the pull request itself. And that's the idea, is to empower you guys to be comfortable to do these things on your own. So we don't need any of these slides since I did this all live. So that basically takes me to my last slide, which is any questions. Thank you guys so much for coming out. I went about 10 minutes over since we started about 10 minutes late, but hopefully that doesn't crimp anybody's schedules too much. If you guys have any questions, you can always ping me offline. I'm always on the ColdFusion Slack team, which is a great resource if you guys aren't a part of that. But other than that, I think that's all I have prepared to present today. So I'll take any questions, and pretty much it.
Okay, I'm going to go ahead and switch also to this, chat-focused view. And folks, you can. Let me clear these votes before we start voting. Sorry, let me clear those votes before we start. But anyway, go ahead, and if you have any questions, go ahead and share them now.
You guys are very welcome. I hope it was useful for you. Let me throw a couple links in here. I also did a blog series a couple months back that basically kind of goes through the exact same process that we just did. If you want to review everything I talked about today, but you don't want to watch this recording, this link here is sort of a step-by-step screenshot guide of basically everything we talked about today. So that can be a nice little reference to bookmark. I did that in combination with a little initiative we did on the Coldbox blog, where actually it wasn't just Coldbox, it was Ortus. We created some super simple tickets, and we encouraged first-timers to create their very first pull request. So if anybody's interested in trying out their very first pull request, I can resurrect that project, and I can come up with some super simple little changes we can put out there. The only requirement that I had done for that project was that only people who had never submitted a pull request were allowed to do it. So it was for first timers to get their feet wet. So if anybody's looking for a place to try this out, holler on the Box Products channel on Slack, or just email me, and I can put a couple super simple tickets out there, like, update this line of documentation, and you guys can do practice pulls. Thanks, Bilal. It's nice to know that GitHub has sample projects too for doing that. I'm not really seeing any questions, Charlie. So
It didn't look like it. You answered all of them. That's now somebody
or they're so confused.
somebody did ask if there was any other topics you cover. So I'd speak to that.
A lot of topics that I cover.
Yeah.
I've done a lot of webinars, mostly on box products. I work with Order Solutions. I'm the lead developer for CommandBox. So I've done a lot of topics on CommandBox. In fact, I presented one here on the online meetup, as well as ColdBox, which I've also presented here in the online meetup. If any of you guys are going, a little plug to Adobe's ColdFusion Summit, which is in, what is it, October, Charlie? Charlie and I will both be presenting there at an Adobe's conference. It's always a lot of fun to be able to get to see everybody there.
Yes, sir. Okay, well, if there aren't any other questions or comments, then I guess we can go ahead and call it. And I will stop the recording, and then in a few minutes I'll have that posted up to the website, and the URL again for that should be... Oh, it's been down there at the bottom the whole time, but I'll change it so it is there from now on at this page as well. But
just make sure the URL works, right?
Oh, I had already. Yep. So it's recordings.coldfusionmeetup.com. But it's not there yet, so I'll get that up shortly as soon as we're done. And then eventually on YouTube and Vimeo. And thank you, Arnold. And again, Arnold,
Charlie is the best.
You guys are kind. I'll get back to you, Arnold, about that certificate for Linda. Get that sorted. Thank you again, Brad, for coming on and presenting. And just in case there's anybody who's waiting to make a question or comment after the recording, let me go ahead and stop it now. And repeat again, as I did at the beginning, that if any of you guys have topics you'd like to present or know of topics that you'd like to see presented, just have folks reach out to me, because I'm happy to have other topics. The only reason we haven't met more often is for the lack of available speakers. And I've got a blog post I did that talks about speaking, if anybody's interested, and there it is. So you can go there and learn more about speaking, how easy it is, answer all your questions, and we look forward to having other speakers on in the future. Okay, well, let me stop the recording, and we'll see if anybody has any questions for you.